morning, my dear students. I'm Daphne Khor. Welcome to my STPM chemistry discussions. Dear students, do you all know what is it? It's a board game called Reverse. It requires the player to strategize the most optimum arrangement of the discs around opponent colored discs to win. Here, in the quantum world of an atom, the electrons will take their optimum arrangement to achieve atomic stability. So, in this video, we are going to discuss about Lewis structure. Lewis structure is a simplified presentation to show how electrons are arranged around individual atoms in a molecule. Now, let's go to the first part. What is Lewis structure? In the Lewis structure, electrons are shown as dots, or for bonding electrons as a line between the two atoms. My dear students, today we will discuss how to draw the Lewis structure of the following molecules. I will use formal charge concept to explain how to draw the Lewis structure for sulfate ion and nitrogen dioxide, even though the formal charge concept is not in STPM syllabus. The reason of using formal charge concept here is there are two possible Lewis structure of sulfate ion. So we can use formal charge concept to determine the correct Lewis structure of the molecules. My dear students, these are the steps of drawing Lewis structure. If you want to determine the charge of each of the atom in the molecule, or there are two possible Lewis structure of the certain molecule, then you can go to step 5, calculations of the formal charge. Now, let's start to discuss the Lewis structure of the nitrogen monoxide. For the step 1, we need to determine the total number of valence electrons in the molecule. There are 5 valence electrons in the nitrogen atom and 6 in the oxygens. Next, draw the skeletal structure of the nitrogen monoxide. You need to determine which atom is the central atom and which is the terminal atom. Next, put 2 electrons between the atoms. Then complete the octet on outside atoms or terminal atoms. Lastly, we put the remaining electron on the central atom. As you can see from the image, the central atom has only 5 electrons, so it does not fulfill the octet rule. That's why we have to go to step 3 and step 4. Now, in order to fulfill the octet of nitrogen atom, we have to move the electron from the terminal atom to form a double bond. Therefore, the Lewis structure of nitrogen monoxide is like this. Next, carbonic ions. There are 4 valence electrons in carbon atom and 6 valence electrons in oxygen atom. 2 more electrons are added. This is because electron due to negative charge. So, total number of valence electrons in carbonic ion is equal to 24. Next, draw the skeletal structure of the carbonic ion. Always remember, we put the least electronegative atom at the center. Then step 3. The 2 electrons has been shared between carbon and each of the 3 oxygen atoms, which refer as single bonds. Now you have to complete the octet on the oxygen atoms, and you can see in the diagram that all the oxygen atoms form an octet. Next step, check whether the central atom has octet or not. If it does not have an octet, then move the electron pair from the outer atom or terminal atom to form a double bond or triple bond. So, this is the Lewis structures of carbonic ions. Next, the Lewis structure of sulfate ion. Sulfate ion is a polyatomic anion having a negative charge of -2. That's why we need to add 2 in the total number of valence electron. For the second step, we need to draw the skeletal structure. As I told you, the central atom has the least electronegativity. Therefore, the sulfur atom is central atom. Now, put the 2 electrons between each sulfur atom and oxygen atom to represent a chemical bond between them. Then you have to complete the uptake on the oxygen's atom so that all the oxygen's atom form an uptake. If we consider double bond in 2 of the sulfur-oxygen combinations, we will get this structure. So, which is the correct Lewis structure of sulfate ion? We need to find out the perfect structure for Lewis structure. Therefore, we need to calculate the formal charge to check whether all the constituent atoms are in their least possible formal charge value. Therefore, calculate the formal charge of each of the atoms in a molecule is the last step of drawing Lewis structure. So, these equations can be used to determine the formal charge of an atom in a molecule. Always bear in mind that we use formal charge as an assessment tool for quality of Lewis structure in cases where more than one skeletal structure is possible. My dear students, always bear in mind that the sum of formal charges of the Lewis structure of a molecule or ion must be equal to the net charge on the molecule or ion. Therefore, in order to determine the correct Lewis structure of sulfate ion, we need to go to last step, calculations of the formal charge of each atom in the molecule. By using the equations of formal charge, we can determine the charge on each atom in the molecule as follows. When choosing the optimum Lewis structure for a molecule, it is important to keep the formal charge on each of the atoms as low as possible. Therefore, this is the Lewis structure of sulfate ion. Next, Lewis structure of nitrogen dioxide. Step 1. The total number of valence electrons in nitrogen dioxide is 17. Step 2. We draw the skeletal structure of nitrogen dioxide. Always put the least electronegative atom, which is central atom, at the center. Then put the 2 electrons between each nitrogen atom and oxygen atom to represent a chemical bond between them. Then you have to complete the uptake on the oxygen atoms. Now you can see in the diagram that all the oxygen atoms form an uptake in the following diagrams. So, which is the most stable Lewis structure of nitrogen dioxide? The electron in nitrogen atom in this diagram is more than 8. Therefore, this is not the correct Lewis structure. So, which is the correct Lewis structure of nitrogen dioxide? Now, we need to assign formal charges to each atom. Always bear in mind that the best Lewis dot structure has the most atoms with 0 formal charge or the closest to 0. So, from the calculations, this structure has the best Lewis dot structure. This is because this Lewis structure has the most atoms with 0 formal charge or the closest to 0. Therefore, this is the Lewis structure of nitrogen dioxide.